And we're going to start our second podcast on connective tissues. Riley's going to help me today. So we're looking at connective tissues, and on your screen you see a variety of different connective tissues, but they form specific function or perform specific functions, such as enclosing organs. They separate layers. They're supportive and they allow for movement. They store fats. They provide insulation. They provide transport. So all of those things make them the most abundant and almost the most important class of tissues because they're found in so many different places. When we look at connective tissues as opposed to looking at epithelial tissues, they don't have an apical surface and a basement membrane. What you find in connective tissues is you find something that we call ground substance. And what ground substance is it's kind of that underlying layer that provides the tissue with some base and some substance, some oomph. And then you have your cells on top of that. And then through the different types of tissue that we look at, you'll see different fibers that kind of integrate into the tissue. And that's a key in helping identify them. So the first connective tissue that we're going to look at are your loose connective tissues. And on this screen you see three different tissues. There's areolar tissue, which is towards the left. You have reticular tissue in the middle. And you have adipose tissue on the right. The areolar tissue, no, I'm wrong. The areolar tissue functions to cushion organs. It's found mainly in between organs, and it helps to package them surrounding, and then it's innervated, and it has lots of capillary junctions that attach to it also, so they can provide the organs that it's surrounding with the blood supply. They have a role in inflammation as well. So the cells that you see inside of this areolar tissue are actually white blood cells. They're macrophages and mast cells and these different types of lymphocytes that help fight infection because they play that role in inflammation. On the right, you have adipose tissues. And a really big way you can tell the difference between when you're looking at adipose tissue as opposed to a simple squamous, because they do look similar because they have all of that white space in the middle, is looking for the nuclei. When you look at fat cells and fat goblet cells like this, you don't see the nuclei that surround the outside the same way you see those simple squamous when you have those nice round cells that have the little nuclei all the way around it. Adipose tissues are found everywhere. They're found underneath the skin because they provide us with insulation and protection. They cushion our organs, and they reserve food. They reserve fuel. That's why when you exercise, you have to go past a certain amount of time in order to use up all of those carbohydrates that are immediate energy and get to the actual fat to break it down. From here we have the reticular connective tissue, and reticular connective tissue forms an internal skeleton mainly around white blood cells and lymph organs. We're looking at things like your spleen that produces white blood cells. The reticular tissue has that loose ground substance, and it provides a framework for those cells to move through. It helps with the transport of getting your white blood cells to where they need to go throughout the body. So those are our loose connective tissues. When we look at our dense connective tissues, there's a couple of things that you want to see the difference between. The cells and the substance are really closely packed together. On the left, we have dense regular connective tissue, and you'll notice that the fibers are parallel. They look like muscle tissues, but they're not. When we look at muscle tissues, you can actually see the muscle cells in between them and the sarcomeres. But this dense connective tissue and this dense regular connective tissue attaches muscles to muscles and bone to bone. They make up your tendons and your ligaments. So they have to be incredibly strong, and they provide for and allow for a lot of stress on the organs. But it's only in one direction. So if you think about where your bones and muscles attach, you'll find lots of dense, regular connective tissue. In the middle, you have some dense, irregular connective tissue. And your dense, irregular connective tissue has elastic fibers that run through it. It contains substance but allows tension in lots of directions. Because it doesn't have those parallel bars going side by side, it allows the stretching and the changing in multiple directions. Think about your joints in your shoulders. You'll find dense, irregular connective tissue because your shoulder joint can move in lots of different places. When you look at your shoulder joint, it forms like a capsule, and within that capsule is where you find the dense, irregular connective tissue because it allows for movement all around within that joint. It also is found in the dermis of the skin, stretching, pulling, different directions. Think about the function and the form. Remember, those things go hand in hand. You're rolling off the bed. The last one we're looking at is our elastic cartilages. When we look at cartilages, you have 3 different types in front of you. You have hyaline cartilage, an elastic cartilage, and a fibrocartilage. The hyaline cartilage, what you see is a really hard, almost glass-looking ground substance. Sorry. And that glass-looking ground substance is what makes up the base. And those little white circles are what we call lacunae. And lacunae are where the actual cells of the cartilage, okay, that's enough, the cells of the cartilage form. When we look at hyaline cartilages, they are, apparently my husband is having fun with this. They're in charge of support and reinforce and resist stress. They make up the embryonic skeleton. So if we look at Riley, she's very flexible, and she doesn't allow, there's not a lot of hard bone that's actually formed in her because it's made of hyaline cartilage, and it's a safety thing. And, humans are amazing creatures. Those bones are made of the cartilage, so the long bones that they're going to have for their life don't get damaged when they're young with all of the crawling and falling and all of those things that kids do. We still find hyaline cartilage on the end of long bones. These are things like your arms and legs especially. And then you find them in your nose. This is formed, the bridge of your nose is hyaline cartilage. In your ribs, that connects one rib bone to the next, is hyaline cartilage. And then in your trachea and your larynx, holding your openings for your breathing tube. Yeah. In the middle, we're looking at elastic fibrocartilage. Elastic cartilage. And elastic cartilage has more elasticity than hyaline cartilage. You'll notice the space in between looks like it's further apart, allowing more flexibility. This is what you find in your external ear. It allows it to be way more flexible. And in your epiglottis, which is the covering that forms over your esophagus when you eat, so you don't swallow and food goes down the wrong pipe. And then the last one we have is fibrocartilage. And fibrocartilage is very similar to hyaline cartilage. It's hard to tell the difference between hyaline cartilage and fibrocartilage when you're looking at it under a microscope. But what you want to see is less space in the ground substance between the lacunae. And then they absorb shock and compression. Because they have that space, it makes them really, really strong to absorb that shock. And when you think about absorbing shock, for me, I immediately think of my back, and it forms the discs that sit in between your vertebrae and in your knees. So when you jump up and down, again, you have your knee joint that sits like this. That cushion of fibrocartilage sits in between there, and it's really strong to absorb all of that compression. Last up, we have bone, and bone has so many functions besides just providing you with a framework for movement. Yeah, that's right. A framework for movement. They also are made of all of these little osteocytes. So the dark circles that form around the bone cartilage are actually cells, and they create vascularized portions of the bone tissue. Again, functions of bone: support, Protection allows you to stand upright, protects your important organs, your brain and your heart. Think about your stronger bones in your body. They provide for movement of your arms and legs, your head. We'll talk about the different joints and how they act as levers when we get to lab. And then they produce blood cells. There's not, in the bone marrow of bone, we produce blood cells, and we'll talk a lot about bone when we get to the skeletal system. And then the last piece that bones do is they store calcium. Calcium is important for a lot of the cellular activities that happen in your body. Yeah, so this was your connective tissue, and I hope you enjoyed this podcast.